Hey everyone, in this video, we're going to look at how we can parametrically draw landscapes and how we can parametrically populate a field with objects, be it line drawings or 3D objects. By the end of it, you should be able to just kind of draw a circle, close it, and then with our script, be able to populate it uh, just like that. And to iteratively use this for elements such as drawing a forest or drawing people, scattering people onto a landscape, or scattering cars onto a landscape, or buildings, or any sort of context that might have degrees of repetition but some variation. That's kind of the goal of this um, video. So sit tight and hopefully you learned something. Okay, so we're going to start with the site, some site data, and what I have in this example is just some contours and some circles where I want trees to go. The first thing I want to do is I'm going to simplify all these little tree areas to be basically regions. And you don't necessarily need to start with these areas. It's just to kind of create a boundary, which is the important part for scattering your detailed trees, which is what I have right here. So what I'm going to do is I'm just going to start using Grasshopper. I'm going to open up Grasshopper. I'm going to click the trees. I have them all as a group. And I'm just going to do two things. So I'm going to type geometry. I'm going to set multiple geometries. Now they're all being referenced. I'll just leave it like that for now. And then I'm basically going to get the area of each one of them. And why I'm doing this is because I just want to make them a bit larger. I just want there to be a bit more overlap. So I'm just going to scale them all from their centers. So I'm just going to take the centroid of each one and plug that in as the center point for this scale here. That's the scale component. I'm going to plug in the geometry, and you can see now all of them have currently shrunk because this is defaulted to 0.5, but maybe we want to do a factor of 2. So I just typed in 2, and there you go. I'm going to just hide these for now. I'll turn this off so we can only see what we have enabled. And now it looks like a huge mess, and this would just cause a lot more computation time, and it's relatively overcomplicated for just wanting a boundary region. So, well, we could have used, there's two ways we could have done this, to be honest. The first way would have been we could have just used the center point of all these circles to scatter, which is one way. And maybe I'll start with that as a matter of fact. So we have all these points here. And perhaps we just want to replace these simple trees with these types of trees here. And so what I'm going to do is I'm going to type this plugin called Scatter, and I'll leave a link in the description. And I'm just going to type that one more time just so it gets out of my way. Here, let's get rid of all this. Let's try that one more time. Scatter. That's better. Okay, and this may look daunting, but it actually takes like 2 steps to get it started. So the first thing we want to do is we need to reference our trees. And our trees are block instances. And block instances typically can't be referenced in Grasshopper. It's a bit of a workaround, and it's a bit less intuitive. So what I'm going to do is G means geometry is GUID tree. And what that means is this is asking for the block instances. So I'm just going to right click it, say set multiple GUIDs, and then I'm going to select them all and press enter. And now what's actually happening is it's not loading these block instances into Grasshopper, which it has done for the circles and such. That's why when I click this, nothing glows. What it's actually doing is it's just referencing these in the Rhino document. So you have to make sure that these are always on when you're using this component. You can't hide these once you've linked them. The second thing we want to do is input the plane, which is what P stands for, target planes. And we have now from the centroid all the points we want to move it to, but we have to convert those points, which are just XYZ coordinates, into a plane. And so while they're slightly similar, we do need to create a plane because it'll specify the orientation of our plants. Because right now, if we just gave this, it wouldn't know if it wants to go up or down or left or right, and like that might be a bit more complicated from the get-go. But then it's great because then you could actually have these rotate based on the topography and stuff, or whatever you're interested in. So what I'm going to do is I'm just going to type XY plane because I just want them to be facing upwards. So I'm going to click up XY plane, and then I'm going to plug in the centroid. And then what you'll see is just all these, right? And you can see now, so there's X, Y, and then Z would be facing up. And Z facing up should be the orientation that we're looking for. And if not, we can just undo it. So I'll just plug this into there. And then we can turn on the preview. Preview is set to true. And there you go. So that's the start of it, just like that. Some things that you can control now, if you want to randomize these, there's rotation. So it's going to actually rotate all of these elements for us. But I actually have a special type of tree. What this includes is every single possible orientation you could want for a tree. So, here's our front orientation, right? Here's our, side orientation, side elevation. Our southwest axo. So if I go to isometric and type southwest, you can see here, they're facing directly to the camera. And so what this is that this is just one tree instance with all these different orientations all laid over top of one another. And if I keep going, you'll see it's just kind of smoke and mirrors. There's one more. So because of that, I have all these different orientations saved so I can easily refer to each one. This kind of becomes like a BIM system, which is kind of novel. And so because of that, I actually don't want my geometry to rotate at all, because otherwise if this is rotated 15 degrees or something like that, then it won't be perfectly, it won't be a perfect elevation. And so for that reason, I am going to just disable all the randomization of the rotation. So scale rotation min, I'll say 0, and then rotation max, I'm going to say 0. So you can see now they're all facing just like that. The scale, we can control the scale of X, Y, and Z separately. So I think that's pretty good, and that doesn't really mess up with the smart objects that I'm working with. And what I'm also going to do, I'm just going to, in general, I scaled these up, but I'm actually going to make them a bit smaller. And let's just reference them again, I think. So multiple GUID. Yeah, there you go. So that's kind of an example. There's a lot of refresh things you have to be considerate of because of the way it's just referencing the geometry in the Rhino document. Okay, and so now that we have this all set up, all I'm going to do, I'll just create a new layer in preparation for it. I'll just put it here for now. So now when I click run, and then I'll turn it back off, and I'll turn off the preview. Okay, and there you have it. So one thing to note, that probably took about a minute for this to scatter, and that's largely because these trees that I'm working with are pretty detailed to kind of be scattered so much and to be exact replicas of what the circles were. It's just a lot more geometry. And despite the fact that block instances are better for scattering and preserving memory, anything of this amount can certainly have sort of memory problems. Just to kind of show you, this is full of different hatches and lines and so forth. So I'm going to, while you could just resolve this by having a simpler tree, I'm also going to show you a way to reduce the amount of trees and so forth. So I'm just going to select this all. I'm going to delete it. Okay, so for the second method, I've just simplified it into a post as opposed to a complex tree, just to sort of expedite things when we're working on scattering things like this. But this could be any curve or CAD block or anything you either draw or find online. So for this next example, what we're going to do is we're going to draw a boundary. So I'm just going to call this scatter bounds, and you can name it whatever you want. And what I'm going to do, I'm just going to turn off OSNAP and Ortho for a second, and I'm just going to try on sketch, and I'm just going to quickly kind of just sketch a line, and then I'll just type close curve to close the curve there. You can see that. You can see that there. And I'm going to sketch again, and I'll just do this. Maybe I'll fast forward this. Okay, so I've just kind of created a region. You can see here, and what I want to do is I consider this region a place where I'm going to populate all these trees, and I'm going to create a series of points in there. And one of the limitations is that it's relatively, we're going to, relatively one way or another, this is kind of going to be of equal density. We could be a bit more complex and make sure that, for instance, this area is less dense based on an attractor, but I think for this example, we're just going to keep it of equal density in this region. Okay, so we're going to go back into Rhino, to Grasshopper. I'm going to type geometry. Okay, so maybe I'll bring that over there. Okay. So we have this geometry. I'm going to set multiple geometry. Let's try that again. Set multiple geometry. Selected, there we go. Oh, that's an interesting one. Okay, set multiple geometry. Just gonna click it. There we go. It's referencing the B-rep. That's why I was having that problem, or the block that I just hit over there. We just accidentally clicked it. And okay, so we have this. And now we can do populate 2D, which is just a command to populate this region with a number of points. And right now it's treating these regions all as the same. And what we actually want is we just want this one region, right? And then we see that these areas, there's no trees, so we want to actually take away the points out of them there. And the two things you're going to notice, first of all, is that it's actually populating it outside of the curve, because you can see here, and that's just because populate 2D always will take the B rep, or the bounding rectangle of that geometry. So what I'm going to do, so we can adjust the number of points, so I can do like 1,000, and that'll specify how many points we want. So we have 1 point right now, and if we get closer to 1,000, there we go. What you might notice is it's actually not getting the full extent. So what I'm going to do is I'm actually going to grab the bounding rectangle of our initial geometry here, and there you go. So, and then you can just kind of compensate by overpopulating it. Okay, so like this is basically it. The next step we need to do, I'm just going to save, and I'll just save this. So now we want to remove the points that aren't inside of our curve. So there's two steps we have to do. We have to remove the points that are completely outside of all the curves, and then remove the points that are inside of the curve but inside of the nested curves. So first let's start with the curves that are outside of every curve. So we'll just type in point in curve. And so the points we want to test for, and make sure this point in curve and there's point in curves. See, point in curves isn't what we want. You actually want point in curve. This might work for your case if you have multiple spaces and such, but let's just do, we just have one right now. So we'll just do point in curve, and you can look those up to figure out the difference between the two. It works for you. So I'm going to grab the points. Here we go. And I'll grab the initial curve. There we go. I'm just going to turn it off, turn off the preview that shows everything. And now all I'm going to do is dispatch this list. So the R is basically saying yes or no. And the way it's saying that is either by saying 0. I think 0 says yes and 2 means no. But either way, we can kind of figure that out in a second. So we'll plug it into there. And we'll plug this into there. And plug in the geometry. Oh, sorry, that's not what I want to plug in. I want to plug in the list. There we go. And there you go. So 0, 2, 0, 2. So that means 0 means it's within, 2 means it's without. it's not contained. And just like that, you can see we started with this, and now we're down to that. Super easy. The next step, we're just going to repeat the same thing, but now with the other curves. Maybe this will be a good time to say point in curves, right? So point in curves, because now we have multiple. So let's see if this works for us. So we're going to grab the points, because now we have that as our system. And we actually have to reference these curves because we haven't done it yet. So I'll do set multiple geometries, 1, 2, 3, 4. And let's just plug this in here. It actually still might be handy for us to just do point and curve, but let's give it a try. So we'll do dispatch. We'll plug in the relationship and plug the A into here. Okay, so that's the, okay, so this is good. So that's the inverse of it, right? And then that means we want this. And so just like that, we've now got a system that we can work with. And we can start to adjust accordingly. Now that we have that, it's just the same as we did before. We can do scatter. These are our new points. So we're going to create an XY plane. We'll plug that in. Here's our tiny little tree, right? And I'll just set one GUID. That's our tree. And then we just need to specify the places that it's going to. We'll turn our preview on. I'll leave the rotation and stuff on. I mean, it's a circle, so you won't really notice the rotation anyway. Okay. And we see that we can start to adjust it based on the density that we want. And you know, this right now, this is just one type of tree. But then again, we could also do some spheres. I'll just change that layer here. Okay, so block. I'm just setting the base point. Oh, snap isn't on. Okay, sphere. In reality, actually, I want the block base point to be at the bottom, right? Because that means that's where it's going to be moving to, is the bottom point. And the same, okay, so block, add base point, cube. And you know, you could put more effort into this if you cared. And yeah, set multiple GUIDs, 1, 2, 3. And go into preview. And so there you have it. And you'll see this geometry is pretty light and quick. So yes, I could, you know, I'll even up the ante a bit. Let's put up to 1,000. And then I'll click run, and then I'll just turn it off. And there you have it. So those are two different ways, you know, depending on what levels of information that you have to start with, whether it's like just these individual, you know, if it was surveyed and you have the point of every single tree is one, or just to get a rough idea, a rough approximation, you can do that. And then frankly, the cool thing about parametricism is now we can start to kind of, you know, maybe change the density of this a little bit. So I'll turn on sketch again, and maybe this area we want to have a bit more dense. So I'm just going to sketch this, and I'm going to close that curve. And this is the cool thing, is you're kind of just drawing now, and this just does the rest. And it's just handling. So I'll turn the preview back on. So you can do that, and there you go. And you can just click run, turn that off, turn that off. And perhaps the one last thing we can do just to make this a bit more flexible is we could actually do it by area. So as opposed to having just like a absolute count, what I'll do is I'll do area, and then we can see what kind of values we're getting out of this. So 62,000 would probably be too much. So we could do, for instance, like the square root, and then that'll get us 249, 213. So I mean, there's no answer to this. It's kind of about just being creative with math. Like we could have just divided it by 10, but square root seems to be a pretty good, seems to be pretty on the money in terms of what we want. So I'll just turn that into an integer. It's not really necessary. And now that we have this, as we start to sketch, we can do sketch again and start to draw over here. Select that, close this. And again, I'll select multiple geometries. You can see the preview again and click run. And there you have it. So that becomes like a pretty quick way to start to adjust the density and so forth. And imagine what this looked like if this wasn't just a bunch of balls. Um, so there you have it. I can maybe upload this script if it's something that you might be interested in. I can provide a link or something for it so that you can use it. Anyway, hopefully that was helpful. Hopefully you found that informative and there was some novel workflow within it all. If you like the video, feel free to like and subscribe, and I'll be happy to make more. And there should be more to come, more Grasshopper tutorials, more Rhino tutorials, more Blender tutorials, Agisoft, and a number of other programs that I like to work on in this channel. So thank you very much. Take care. Okay, so for the second method, I've just simplified the tree to being a post just for now, just to kind of expedite this. The other way was fine. It was just a bit too slow. So here we go. So we have a post. And so for the second example, and mind you, with the other, intense trees, what I would typically do is just have them turned off until I want to print my drawing, so I can keep working on the file. So another example is like right now, what we've done is that one post is coming and replacing every circle, but perhaps you don't have this level of detail, right? Or perhaps you want to modify it. Maybe it was just like an abstraction, and you kind of want to increase the density or reduce the density. What I'm going to show you now is from the previous step where we took the area and then just scaled up each circle individually. And so now you can kind of see these are starting to overlap. And so what we're going to do is we're just going to grab the boundary of all the overlapping circles by using the command region union. And then if I take this and I'll flatten it and I'll specify plane as the XY plane.